Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Now, I want this video thereof to be a specific video whereby we will be now learning how to do what, to take whatever the table that we normally get when we deal with organic chemistry in question 2 and get its name, the Iupac name, the structure, or the condensed formula. Okay, yes. So let's just dive into it. N means Iupac name, S means structural formula, C means condensed. So we're gonna do that for the following what molecules thereof. Okay, let's look at A. Let's look at A. Let's draw its structure first. Okay, it's very hard to name it when it is like that. So let's draw its structure first. So how do I draw its structure? I have to see a clear line or what is happening here. Okay, so this is CH3. Okay, I see CH3, so it means it is CH3 like that. Then I have a C here. Okay, that's C. Remember I said if you have a line like this in a condensed formula, it is what? It is a branch. So, okay, I have a branch like that. I have a branch like that. Then I have a what? I have a BR like that. Then I have a what? I have a CH2. So I have a C. I have a H. I have an H. Then I have CH, then a branch. So it means on that C, I have a branch like that. I also have what? An H. Then I have what? I have C and a branch. C and a branch. But I also have an H. So it will be like that. Therefore, I have a CH3. Okay. So CH3. This is me taking the condensed formula into what? Into a structural formula. Now, am I in a position of knowing how to name this? Yes. Remember, what do you prioritize? This is a haloalkane. On haloalkane, what do you prioritize? You prioritize nothing. You want the one that gives you the least number of substituent. Then let me start counting in here. It's going to be 1, 2, 3, 4, 5, 6. Okay? Then let's see when I count the other way around. When I count the other way around, it's going to be 1, 2, 3, 4, 5, 6. Now let's compare. The red one, let's look at the substituent. I have what? 2. I have a bromo on number 2. Okay? I have a bromo on number 2 when I use red. So I'm going to say when I use red, I have 2 bromo. I also have what? Can you see now this one is going to be what? A branch. This one is going to be what? A branch. This one is going to be what? A branch. Like that. So now how many branches do I have? I have 3 branches, but in different location, 2.4.5. At number 2, number 4, number 5. I'm using the red. I'm using the numbering of red. So I'm going to have a 2.4.5 methyl, okay? So the total here, the total numbering here, it is 2 plus 4 plus 5. It is 11 plus 2, it is 13. This one is 13. Let's see when we use what? Blue. Blue is okay. When I start here, I have number 2, number 3, number 5. 2.3.5, I have methyl. 2.3.5, I have dry methyl. Do you agree with me? I have methyls in 3 positions when I use blue. Then I have what? On carbon number 5, I have what? I have bromo. Okay? So when I add this, in total, I get 2 plus, this is 10, then this is 15. 2 plus 3 plus 5 is 10. I get 10 plus 5, it is 15. So which one gives me the smallest? This one. So it means I'm going to continue with the red one. So you see how easy it is or how nice it is to use this technique thereof. This technique works very, very perfectly for me. It does not disappoint me. So I'm in a position of saying, okay, the Iupac name for this one, it is now Remember, B comes before M. Remember, I said when you name the tri or the bi, you do not consider it, okay? So I'm going to say, okay, let me take these, move them here. Maybe here, I'm going to remove them either way. So I'm going to say, okay, now the name for this one, it's going to be what? 2 promo. 2 promo. Okay. 2.4.5 trimethyl what? Remember trimethyl, then I'm done. I don't need this anymore. Remember the longest chain, it is what? 6. And this is one of the alkanes, but a special one. So it's going to be hexane. Like that. For number A. Okay? Yes. Now let's move on to number B. Let's see what number B has for us. Number B, they have this one, okay? So if they have this, we need, why am I removing those? We need to give now the name and the condensed formula, okay? The condensed formula for this one, it is CH3. Can you see that? Let me come here and say, for B, the condensed formula, it is CH3, carbon, CH3, CH. Can you see that? CH. Can you see now another CH? What? CH3. This is me saying, okay, this is the condensed formula. Now, what is the name? What is the name? Name, I do what? I start counting from where I get the smallest substituent. Where is that? Or rather, functional group. When I say 1, 2, 3, 4, it's going to be between 2 and 3. So it means it is 2. When I start counting from this other side, it's going to be 1, 2, 3, 4. It is between 2 and 3. Can you see it's still the same? It is 2. So it means my answer here, it is going to be what? The longest chain, it is what? 1, 2, 3, 4. It is butan, but, okay, 1, 2, 3, 4 for but. Then I get the functional group on position number 2, and it is in. So I have butene. But 2 in. For B, I have but 2 in. Remember, you start using butane from alcohol going down. So this one is going to be but 2 in. Let's look at C. I hope you are pausing the video and trying them on your, for your job, and trying them first before now watching again. Okay. C, pent 2 in. Pent 2 in. How can I draw that pent 2 in? Pent, longest chain. Longest chain pent, it is 5. 1, 2, 3, 4, 5. Actually, let me remove this. I just want 5 carbons. Then I'm told, okay, pent 2. On carbon number 2, I have an in. And in it is double bond. And in it is double bond on carbon number 2. So it means this will be like that, like that, like that. You should be careful of the hydrogen bonds. Here I'm putting, okay, I'll come back to that. Here I'm putting 1 because can you see now it is already 1, 2, 3, 4 on this carbon. So if I were to put another carbon, hydrogen there, it is wrong. Okay, yes. So you make sure that you know how to count. Now let's do a condensed. A condensed for this one is going to be what? Can you see now when you have a structure, it's easier. You say it is CH3, then here I have what? CH, then here I have what? CH, then I have what? CH2, then I have what here? CH3. Okay, yes, yes. We can also say, okay, well, how about we do molecular formula? Molecular formula will be easy because we'll say how many carbons do we have? All the carbons we have. 1, 2, 3, 4, 5, 6, 7, 8. It's gonna be C8, H. Now count the hydrogens. Now I won't count them because I know the general formula is CnH2n plus 1 X for what? For haloalkanes. So it's going to be C8H2n. It is 16 plus 1, 17 plus X. X it is what? Br. Molecular formula, that one. Molecular formula here, I'll say how many carbons? 1, 2, 3, 4. So it means it is C4. This is butane, it means it will be H8. From knowing the general formula fail, here we'll say, okay, how many carbons? 1, 2, 3, 4, 5. C5, it is an alkene, it has CnH2n, so it will be 10. You can count them, it's fine. Nah, I don't have time. Let's look at D. D now we have CH3, CH2, CH2, CHO. CH3, CH2, CH2, like this, CH3, CH2, CH2, CHO. Let's draw that. Let's draw that. Oh, let's make it interesting and name this. This is what? Haloalkane. Homologous series haloalkane. Homologous series haloalkane. Homologous series I see in. This is alkene. Okay? This one also an alkene. Then here CH3, CH2, CH2, CHO. I'll just do a structure following that pattern. It says to me CH3, 2, 3, then it says CH2, 1, 2, it says CH2, 1, 2, then it says CH1 and O. Can you see that? But O cannot be left hanging like this. It means now, how can I complete the bonds here? I can complete the bonds by saying, okay, oxygen accept can receive 2. So this is that. What is the name of this? Okay, under of which homologous series does it belong to? I'll give you a moment. Aldehyde. Why? Because now the double bond O is on the terminal carbon. So this is aldehyde. But specifically, what name of aldehyde? 1, 2, 3, 4. The name, it is butan. Remember the ending for aldehyde, it is al. And I do not need to say the position it is the position it is 1 because it is always on position number 1. Let's look at E. On E, I'm given, here's E, butan 2-one. This is a ketone. Butan 2-one, this is a ketone. How can I draw that? Butan tells me about 4. So I'll say, okay, 1, 2, 3, 4. Butan 2-one. 2 tells me on carbon number 2. I can say carbon number 2, I have an oxygen because it is a ketone, right? It is a ketone, right? Remember, a ketone has a what? Has a functional group on between carbons. And I'm told it is but 2-one. So but for longest chain 4, then 2 on position of the functional group, then I can complete the rest. Say, okay, this is hydrogen here, hydrogen here, hydrogen here, no hydrogen there, hydrogen here, hydrogen here, hydrogen here, there, there. But remember, ketone also has a name, ketone carbonyl. This is the homologous series, this is the functional group. Okay, yes. Aldehyde has the same name, formyl. This is what? Homologous series, this is functional group. Okay, yes. Let's look at number. Okay, if I were to draw the structural, the condensed for this one is going to be CH3, CO, because it's C and O, then CH2, CH3. I just write whatever I see. No, I'm not writing any bonds there. Number D, number F. 4.4 dimethyl pent 2-wine. 4.4 dimethyl pent 2-ine. Let's draw this. I start where the longest chain it is pent 5. 1, 2, 3, 4, 5. And I have on position number 2, I have an ine. An ine, it is triple bond. Position number 2, I have an ine. Okay, then it means what? Then I'm told that on position number 4, 4.4. So if I started counting here, 1, 2, 3, 4. This is carbon number 4. I can say this is 1, 2, 3, 4, 5. Now I'm told on carbon number 4, I have a CH3 or a branch like that. Also here I have a branch like that. Right? Yes. Then I can do what? I can complete the rest. People, I'm done. Bond there. H, H, H. No H here, no H here. Just a bond like that. Yes. Why am I saying no bond here? Because if I add this, can you see now, this carbon will have more bonds than it's supposed to have. So when I count for this carbon, it's going to be 1, 2, 3, 4. So they are enough. I'm done. This is the structure. Okay, remember the name was 4.4 dimethyl pent 2-ine. Then now the condensed formula for this one, it is CH3. Okay, let me write it here. CH3, C. I'm just writing whatever I see. Then I can say C. I have a what? A branch. Remember branch, I can say you can do bracket. But how many branches do I have? 2. Okay. Then what? CH3. Or an alternative way you can say it is CH3, C, CH3, C. Okay. C. Then C again. But now it has a what? A CH3. It has a what? A CH3, sorry. Here I just say CH3. I only show bonds if I want to show this is a branch, or I use a bracket. And how many branches do I have? 2. I believe you are following. I strongly believe you are following. E, bo. F, bo. Yo, ED, demo. Letters are not coming all right. Okay. Where are we? F, E, F, G, butane. People, we all know G. G is butane, just is butane, right? G. How do you draw butane? 1, 2, 3, 4. Blah, 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 blah. H, like that, right? Yes, like that. Then when I draw the condensed, it's going to be CH3, CH2, CH2, CH3. Then the last one, A, B, C, D, E, F, G, H. Letters are not agreeing with me. H, I have a what? CH3, CH2, COOH. I can see this is a carboxylic acid from COOH. Okay? Indeed. Here we forgot to name, what is this? This is alkyne. Sorry, this is alkyne. Yes. Then there we have what? Ketone. Ketone what? CH3, CH2, CH2. Okay, in the ketone that we had, it is CH3, CH2, CH2, COOH. So now let's draw this. I can already know it is not a ketone, man. Sorry, a carboxylic acid. So it's going to be HCC like that. Can you see? Carbon surrounded by H. Then this carbon, second carbon surrounded by 2 hydrogens. Then the other third one surrounded by 2 hydrogens. Then the fourth one, it is C. Then it says it is O. It is H. Then this one, it is O. But in here, we need 2 of them. Can you see that? You will not do this O, H. We don't have something like this. Okay. So now the name of this one. What's the name of H? I'm gonna start here. One. Okay. So I'm in the chain 1, 2, 3, 4. 4. I'll just say this is butanoic acid. Cool. Done. Like that. And remember, butanoic acid has the same name of what? Has the same name of carboxyl. Functional group is carboxyl group. And this was just an alkane. This is just an alkane. Yes, yes. Now let's look at the second one. CH3, CH2, or CH3, CH, CH3. This is a branch. Can you see now? The first one that we did, they showed a branch by this part, but the second one, they show a branch by a bracket. So can you see now? At least we get to see both of them. Let's look at A. Let's try to draw that CH3, CH, CH, a branch, CO, CH, ganjal. Let's try to follow that. It's going to be CH3, right? Am I incorrect or correct? CH3, CH, and a branch. This is CH and a branch. So I'm going to say, oh, okay. This is CH and a branch like that. All right. Then what? CO, oh, okay. C, remember O, it is likely to be here. CO, then what? CH, oh, okay. CH, I put H like that. Then after H, it is what? A bracket. A bracket. Now, I want you to take careful of this bracket. It is CH, then 3. It tells you we have we have 3 CH that follow each other. How? How? Like this. Let's see if we do this. C, I want you to take note of this. If you do it as a branch, it's going to be C, H, C, H, sorry, C, H, H, like that, H, C, H, C, H. Do we have something like this? No. Therefore, you change that bracket, it is no longer a what? Therefore, that bracket, if it does not make sense, it is no longer a branch. It is now, you say CH, and you want to see CH, CH. You want to see exactly what is happening. They are saying the CH should be 3 of them, okay? Then we have CH2. I'll come back to that. CH2, CH2, then CH3. Right? Yes. Now let me come back to this gap here. I need to count the number of bonds here. Here I have 1, 2, 3, 4. Okay, that carbon is satisfied. Here, I'll say it is 1, 2, 3. Okay, it is not satisfied, but either way, there's something missing here, right? I won't put hydrogen because they did not say it is hydrogen. Here, 1, 2, 3, it is also missing. So if I'm missing 2 of these, how can I replace that? I can replace that by saying, okay, let me make a double bond between the two. Okay, so if I make a double bond between the two, can you see now they become satisfied? 1, 2, 3, 4. So 1, 2, 3, 4, like that. Then similarly, when we count for this one here, it's going to be 1, 2, 3, 4. So they are satisfied. Then we come to this one. I come to this one. I say, okay, this one is satisfied. What about this one? It needs this one here. What about this one? It needs this one here. So what should happen? I should make a double bond like that. So this is basically what was required of us. How interesting. Let's be in the position of naming this. Okay. Sorry. Let's be in a position of naming this. Let's name. I want the double bond to be the smallest. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this becomes a branch. Okay. They won't ask you to name this because wow, it's already it has already exceeded the maximum, which is 8, that you are supposed to know. Okay, let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's fine. Let's just name it as 9 as it is, but you don't have a 9. Okay. Let's just reduce this for our own purpose, because there's no way you'll get a 9 in high in secondary school. Okay, in secondary school you won't get 9. So if I do that, I can recount and say, okay, this is 1, 2, 3, 4, 5, 6, 7, 8. Now remember, I have two ways that I can count. I can count from this way to that way, or I can count that way. You should consider both ways. Okay. 4, 5, 6, 7, 8. The question is, I don't think they even asked for a structure for this one. I mean, an Iupac name for this one. Here, let's try to name it. Let's see if I use the blue one, it's gonna be 2. I have a what? A methyl. Then what I have on number 3? Number 3, I have a ketone, because remember, ketone, it is between. Okay. On number 4 and number 5, which is number 4, it has a what? An in. Number 5, number 6, it has an in. Already there is no name for this one. Why? There are more than 2 functional groups in one element. So there's no way we're gonna be able to name this. So yeah, we're just gonna draw the structure as it is only. Okay, yes. Cool. Now let's move to number B. Number B, I have a what? 2.2 dimethyl pentan 3-ol. Pentan, I start here, pentan. Pentan means 5. Okay, so okay, I'll say 5 carbons. 5 carbons. 2, 3, 4. Make sure you have enough space, because we have a bigger page. Do not do this. Why? Just create space, man, for your own work, so that you'll see, man. Okay. Then I'm told on that carbons 5, it is all. I know all has single bonds. It is on carbon number 3, I have alcohol. Okay. I can say, okay, before I fill up this, on carbon number 3, 1, 2, 3. Can you see it is 1, 2, 3 when I start from here? Also, when I start from here, it is carbon number 3. Yes. On carbon number 3, I have a functional group of all. Functional group of alcohol, it is OH, right? Yes. Then what again? I'm told that on carbon number 2.2, I have dimethyl. So on 2.2, it means I have number 2, I have a branch here, here, there, that, like that. Yes, indeed, like that. Can you see that? Let me get this one a little bit closer, maybe. Yes, yes. Aha. This is that. This is the structure. This is the structure. Can I do a condensed for this structure? Yes, why not? What? CH3, then C. Okay, the C has what? CH3. How many of those? 2. So it means I have how many branches? 2 branches. Or I have what? CH, OH, like that. Okay, you can start with OH and then H. That's fine. Then I have what? CH2, CH3. Or another way I can write this, I can say, okay, I say another way I can write this is CH3. On this carbon, I have what? A CH3. And I also have a what? A CH3. This is easier, okay, than the bracket one. CH3, then I have what? A C, H, O, OH. You can also show OH like saying O, OH on that carbon, okay? CH2, CH, CH3, like that. A substituent or a bracket, sorry, a substituent, which is, remember I said a substituent can either be a branch or any alcohol, OH or halogen. So it is this or that. Let's look at number C. Number C, I can see what kind of this double bond O. It can either be ketone or aldehyde, but now it's going to be ketone. Why ketone? Sorry, aldehyde. Why aldehyde? Because now the double bond O, it is at the terminal carbon. So I have 1, 2, 3. So I have propanol. For C and G, I don't go anywhere. I say I have propanol. Propanol. So what is the structure of propanol? It's going to be CH3, CH3, CHO. Am I correct? No, CH3, CH2, CHO. CH3, CH2, CHO, like that. I move to number D. And say I have C5H10. C5H10, it is in the general formula of CNH2N. I mean, this is an alkene. So I can say, okay, C5H10, I can draw that and say 1, 2, 3, 4, 5. Okay. But now I'm not, okay, so I know I have 5 hydrogens, okay? So I want to believe in this question, you were told that, okay, let's say this is a, let's say this is a secondary alkene. Okay, it's fine. Let's say we can put this in many ways. We can say, okay, since while it is C5H10, I know it is an alkene. C5H10 comes from the general formula CnH2n. Which one has a formula like this? Alkene. So I can put it like there and say, okay, it is like that. Please fill up the hydrogen, I'm tired. Like that. Or someone might say, how can I, what about I put my double bond here? How about I put my double bond there instead of carbon number 1? Then you are still correct. Here it is short of 1. What if someone says, what if I put my carbon on carbon number 3 instead of carbon number 2? Like that. Like that. 1, 2. Oh, so this is the same as 2. If I take this here, it's still 5. So you can either draw this one or that one, okay? Yes. Now, how do I draw the what? The condensed structural formula for this one? I'm gonna say, okay, it is CH3, C, H, C, H2, CH2, CH3. Let's look at number E, probably the last one. I'm tired. Number E, it is, okay, the name of this one. Let's see. When I start here, it's going to be 1, 2, 3, 4, 5, 6. Okay. Can you see I have a Cl, I have a HBr, I have a branch. Okay. If I start counting from here, it's going to be 1, 2, 3, 4, 5, 6. So I want the one that gives me the least. Let's start with red. The red one has 2 methyl. Okay. 2 methyl. We have a branch there. We also have 2 chloro. Can you see? 2 chloro. I have what? 5 bromo. I cannot say 2.5 dichloropbromo. I only use di if it is the same compound. Like if it was Cl here, I was gonna say 2.5 dichlor. Then the total here it is 9. Okay, the red one, the total it is 9. Let's see the black one, the total it is how much? The black one is gonna be 1, 2. I have 2 bromo. And I have what? 2 bromo, 1, 2, 3, 4. Number 5, I have 5 chloro. I have 5 what? 5 chloro, also 5 what? 5 methyl. So the total in here it is 10, 12. So it means I'm going to count from the red because it gives me less. less, not less, less. Cool. So it means the name for this one, I'll say now, it is what? When I start counting from here, it is, can you see now the name here? It is going to be something like, I'll write it here, then I'll copy it. It is going to be something like, remember the alphabetical order, B comes before C and myth. So it's going to be 5 Romo. Let me write it here, 5 Romo, 5 Promo, then C comes before M, then 2 Chloro. How long is this name? Jesus Christ. 2 Chloro. Then I have what? 2 Methyl. Longest chain. 1, 2, 3, 4, 5, 6 hexane. Oh, my goodness. How interesting is that? How interesting is that? Hmm? Can you see now? 5 bromo, 2 chloro, 2 methyl hexane. Now, I did not say, why did you, okay, the question might say, why do I not start with 2 because it is the lowest? But remember, when I name, I consider what the letter B comes before C, comes before M, like that. Yes. Good. Now, I can also do a condensed. A condensed, I won't do it. I want to believe. So, see, I think letters are not my favorite now. FCH3CHOOH, this is the carboxylic acid. Automatically, I can see. How can I draw that? This is very straightforward. CH3, CH3, like that. C double bond O, O, H. This one, it was easy. Okay, yes. Now let's name them. Let's name them. Or they fall under which homologous series. This one I see double bond. This one does not have a homologous series. It is many things in J. This one falls under what? Alcohol. Why I see an OH, and I know the OH has a functional group of hydroxyl. Functional group, it is hydroxyl. Homologous series, functional group. This one, propanal, aldehyde. This is the homologous series. Then the functional group, it is formyl. What? Functional group, formyl. How cool and nice is that? 5-bromochloromethyl. I see halogen, halogen. So this is a haloalkane. Okay. Then this one I see double bond OOH. This is a carboxylic acid. What kind of carboxylic acid? What kind of carboxylic acid? Oh, remember the functional group. This is homologous series. Functional group, it is carboxyl group. Functional group. Now, did they give us a name there? They just did give us a condensed. So let's name this one. How can we name this one? When you name this one, it's going to be 2. 2, it is eth. So it is ethanoic acid, like that. How nice is that? How nice is that? Very nice. So thank you very much, folks. Let's meet again on the next video where we'll be discussing now physical properties, okay? Yes. So thank you very much. Join me again on the next video. Thank you. Hope you enjoyed.